All right, class, so this is a weak-based problem, and it's a slightly different type of problem. We're going to be solving for an initial concentration, which is not the normal sort of way that we're used to doing a problem like this, but it is, pretty straightforward, so let's go ahead and work through it. The first thing that I'm going to sort of notice about this problem, I'm told it's a solution of aniline. I might not know what that is, and that's okay, but the next thing I'll notice is that it has a pH of 8.65, so I'm going to say right away, or notice that is a basic pH. So that indicates probably that this is a weak base, right? So if this is a basic pH, aniline is probably a base, right? A weak base. And if I look at my little table here, so this is the table that you're given, we've got aniline and we've got our formula C6H5NH2. This nitrogen, that's going to be what's acting as the base. It's going to be accepting the proton. And I'm given a Kb. So the first thing that I would really want to do is write out my Kb reaction, my Kb equilibrium reaction. NH2 plus H2O is going to be in equilibrium with C6H5NH3 plus OH minus. This is my Kb. It fits the general form of a Kb. Base plus water goes to Hb plus OH minus. That's going to be Kb. And I know my Kb value, 7.41 times 10 to the minus 10th, from my table that was given. So that's sort of the first thing, sort of orient myself to the problem. The next thing I would do is I'm looking for the initial concentration. So the way that I would sort of indicate that is I would put a molarity in brackets. I would say this is what I'm looking for, that M initial molarity. And then I can sort of fill out the rest of my ice table. I can say, well, we're not going to worry about water. I'm going to have 0 and 0 here. My change line is going to be minus x, and plus x. And then at equilibrium, I should have some initial molarity minus x, and x for my relative concentrations there. Now the next thing becomes, well, do I have any information that can help me figure out what this x value is? And we do, in fact, because we have the pH. So if I know that the pH is equal to 8.65, then there's a number of ways I can solve this. I can convert that to a pOH, or I can just say, well, from here, I know that the concentration of H plus should be equal to 2.24 times 10 to the minus 9th. And then from there, I can solve for the concentration of OH minus, which is equal to 4.47 times 10 to the minus 6th. So there's, like I said, a number of different ways where I can convert these different numbers. I could find the pOH, 14 minus this will be the pOH. To convert from concentration of H plus to OH minus, I've used the relationship that these concentrations will equal 1 times 10 to the minus 14th. All of those different sort of relationships, right, Kb, Ka, Kw, they're all related to one another, and so it's a little confusing maybe to keep track of them all, but just make sure you're comfortable converting, doing these conversions here. This is my x value. This is my concentration of OH minus at equilibrium, and that's going to equal x, right? So this is my value for x. So wherever I have x, I can actually plug that value in and find what my concentrations are. So the last step is I want to solve for this m. The way that I'm going to do that is I'm going to write out my equilibrium constant expression for this reaction. So if this is my Kb, that should equal x times x over my initial concentration m minus x. I now know my x value is equal to this 4.47 times 10 to the minus 6. I'm going to plug in x and solve for the concentration of m, my initial concentration. So if you do that, I'm going to skip over the math that's going to be done there. If you have questions about that, definitely let me know. And m should equal 0.0269 molar. So that is my final answer. That's what we're looking for. That would be the initial concentration of aniline in this problem. Now, one really interesting thing that you can do is you can just sort of do this problem the normal way. So now we say that this is my initial molarity. We'll plug that in here and solve your ice table and see if you end up with the same pH, right? You can imagine saying, well, what would be the pH of a solution that's originally 0.0269 molar? You guys can solve that problem. So go ahead and do that and see if you get a pH of 8.65. I think that'd be a good exercise. All right.